Okay, Assalamualaikum class. Now we will continue with the partial differentiation for implicit functions, right? Okay, let's recall back the implicit function or the implicit differentiation that you have learned in calculus 1. Alright, in calculus 1, you have learned, let's say if you have x squared plus y squared equals to 2, for example. If you want to find your dy dx, if you want to differentiate, you will differentiate each terms, okay, with respect to x, right? So for example here, if you differentiate x squared, you will get it is 2x. But if you differentiate y squared, it will be 2y. Okay, since there is no x there, then you have to multiply with dy dx. Okay, so similar for 2x, it is actually when you differentiate x squared, you will get 2x times dx over dx. So it is actually you have the dx over dx. But since it is 1, dx over dx equals to 1, then usually we didn't write the number, the function dx over dx. Alright, so next, the right hand side will be differentiate 2, you will get 0 because it is a constant. Then you will get it is 2x plus 2y dy dx equals to 0, and lastly you will write your dy dx as the subject, and it will be negative 2x over 2y, and simplify you will get it is negative x over y. Okay, this is the implicit differentiation that you have learned in calculus 1, right? So now let's see what is the partial differentiation for the implicit functions. Okay, all right, let's say we have z equals to fxy, meaning in a function of z, okay, we have x and y. Alright, okay, so if you draw the tree diagram, okay, you will have in the function of z, you have x and you have y there. Alright, okay, so to differentiate, okay, if you want to differentiate with respect to x, okay, so if you differentiate with respect to x, okay, it will be dz dx will be equals to partial dz dx times dx dx plus partial dz dy times dy dx. Okay, so this is the chain rule that you will get when you differentiate with respect to x, right? So when you simplify the dx over dx, you have dz over dx is a partial dz dx plus partial dz dy times dy dx. Okay, now you want to find, okay, basically here we want to find dy dx. This is the thing that we want to find. Okay, so dy dx is usually used to find the gradient of a tangent line, a slope of a tangent line for a curve, right? So how to find that dy dx if you have the functions of 2 or 3 variables, right? So what you can do is we will assume your fxy equals to 0. Okay, so we will assume your fxy equals to 0. So if your fxy equals to 0, okay, that means you will get your z equals to 0. So if you differentiate anything your dz dx will be equals to 0. So that means now you will get your partial dz dx plus partial dz dy times dy dx equals to 0, right? So when you simplify, lastly you will get a formula, which is the formula is dy dx will be equals to negative partial dz dx divided by partial dz dy, or you can write as negative zx, okay, divided by zy. Therefore, in general, we can say that the implicit differentiation using the partial derivative, okay, it will be if fxy equals to 0, okay, then to find your dy dx, it will be equals to negative of fx divided by fy. So this is your formula.